Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hi, everyone. Welcome to the first episode of Season 2 of the Probability Podcast. This week, we're going to talk about neural interfaces, cutting-edge technology that is bridging the gap between human brains and machines. From improving medical treatments to opening new frontiers in communication and control, neural interfaces are poised to transform how we interact with technology. So, as the generator, I'll pose the questions for discussion today. What are the different ways we are interfacing human brains with computers today? How might AI and quantum computing enhance brain-computer interfaces? What benefits could be realized for people with disabilities? Could this technology be used to give people superhuman capabilities? And what are the challenges and concerns with integrating this technology with human biology? What do you think, Mr. Discriminator?
Well, I think that when you look at the brain-computer interface, we're just at the very, very beginning of where we're going today with that.
Are we going to create the $6 million man yet?
Easily. We're going to go beyond, Steve Austin.
Beyonce, we're going to create the $10 million, the $1 billion man.
The $1 billion man, exactly. So we're looking at brain-computer interfaces. Of course, they call them BCIs. There's multiple types of this. There's multiple technologies involved. And the idea is, of course, is you have, the person's ability through thought to trigger an action, right? And that action could be to control a system or could be to manipulate a prosthetic arm, right? It's just that wide open.
Yeah, because everything's controlled by the brain, right? So essentially, from what I've learned through the research on this, really like the brain, everything coming out of the brain is sort of electrical signals in a sense, right? And then depending on what part of the brain is coming from, the signals are a bit different. And that's what they've done is sort of in a lot of cases tapped into that center of the brain for control, or there's recent advancements tapping into the center of the brain for sight. And if they can interpret those signals and understand what they mean, then they can interface that with a piece of technology to, control movement or something on a computer or that type of thing, right?
Full duplex, though, just gets really interesting because now you're putting information back to the brain, right? If you send a message to your prosthetic arm and your prosthetic arm reaches for something and it feels heat, right? Or it grabs something, it can feel the pressure, or if it's wet, right? That's where we're going, right? It's the ability not only to, direct something, but also get the sensor feedback, right? And that two-way communication is incredibly, well, it's very, very difficult right now, but you can almost imagine the application here. It's unfathomable how far this could go.
Yeah, absolutely. Especially for, like we sort of mentioned off the top was, especially people with disabilities and, obviously prosthetic limbs of different types have been around for a while and it's sort of moved into areas of robotics and things. But this will take things to like a whole different level. And we're already seeing it in its infancy. So I can only imagine what it's going to be, given another 3 to 5 years or what have you, right? AI is accelerating every area of technology. And certainly this is no different, right?
Yeah. So when you talk about AI, what you're talking about is that third party, right? So you got this third party, something like a translator, right? So the information is getting translated from the brain to the device, and then from the device to the brain, right? And that translation, depending on the type of interface, has to be turned into that, like that message has to be turned into that medium. And what does that actual message look like, right?
Hmm.
And that's where it really gets really interesting. You think about it. If you have, the very basic ones. I mean, I know you watched the Elon Musk went through all that research
Neuralink, yeah.
with Neuralink. Maybe you can jump into that a little bit, but the idea being that even that is fundamentally simple. What we've implemented so far.
I mean, it's used as machine learning as well, to an extent, right? To learn the person that it's interacting with. So that was one of the things that they talked about in this. There's this huge podcast with Lex Friedman interviewed Elon and the rest of the team. If you're not a fan of Elon, you can skip to the rest of it. At the very end, he interviews the people have their various opinions on Elon. What they're doing here is pretty magical, though, even though it's fairly basic and rudimentary to start. But he also interviews the gentleman at the end that actually had this Neuralink implanted. He's the first human to have this particular device implanted in his brain. And they did talk a lot about how over time they keep tweaking the system, using machine learning and other technologies to learn more about him in particular. So over time, this sort of relationship between him and the device gets improved over time. Because it learns more nuances about him in particular and the way he communicates. I guess they said that everybody's a little bit different. So it's not really, at least right now, it's not really a one size fits all, in that it'll have to get climatized to each individual, based on their, nuances in the way they communicate, I guess, and that sort of thing. So they did mention that it actually got better over time. So when he first woke up and they started testing, it was working, but over time it started to get much, much better.
And he's also adapting to it, right? He's
Yeah,
also
yeah.
learning how to best manipulate it, right, and communicate with it. And that's where the neuroplasticity of our human brain is absolutely phenomenal. Because
Hmm.
on the technical side, I don't think you have that range of adaptation that we do on the biological side. And this um, is proof that we're able to, modify ourselves to take advantage of that new capability,
Yeah,
right?
like he was almost like a space explorer, right? Or a new baby, just looking at things for the first time. There was no precedent for it, right? And I think
Yeah.
I actually mentioned this in an earlier podcast. We were talking about something along these lines. But what was really interesting, there was a moment in the podcast where he's talking to him about his experience, and he said that initially when he started using the device, he would, with his brain, he would send a signal to his hand, even though he was quadriplegic, he couldn't move his hand. He would send a signal to say, I want to move this cursor, because that was his natural inclination, because he was a functioning, person at one point that used computers and things. And he actually realized at a certain point, somehow figured out how to bypass that step, which is really phenomenal when you think about it. It really says something about the human brain. We're talking about how smart
Mm-hmm.
AI is and everything, but which, it hasn't reached sentience, but for him to figure that out, and then he reached the point where he could move the cursor just by thinking about it, which was the whole purpose of the technology. But there's no precedent for it. We don't know how to do that as humans. Anybody's instinct would be to try and say, okay, I'm going to move this cursor, and your brain would send that signal to the hand, and there was some latency in that interaction. And when he figured out how to do it more directly, there was none of that latency. So it sort of creates this idea that maybe in the future, we could improve upon our own interactions with technology with sort of some sort of neural interface. Now, hopefully, it gets to the point where you're just going to wear something on your head, perhaps, because if you look at the if you look at the process whereby they have to drill a hole in your skull and insert wires into your brain, I mean, that's a very delicate procedure. Even in that, they talked about that initially there was some issue in that some of the wires that get input. Now these wires are smaller than the smallest human hair, that actually retracted. In other words, the brain was sort of rejecting it, right? So you're still trying to like interface hardware into wetware, as it were, right? And it's not made for that.
Yeah. Well, when we think about that whole idea, like you referenced, the idea of these electrodes. I mean, the idea was that, we're taking like the shotgun approach, so we'd have all these different electrodes to all these different specific cells, attached in that particular areas of the cortex, and you know, in some cases, some of those just didn't take, right?
Mm-hmm.
So when you start looking at the technology, the adaptive process is really involved not only on the fact that we've got a neural nets chugging away here and CNNs and so on and so forth, trying to learn and become better interfaces, but also we have our own minds, our own brains. Now, like you said, this is invasive, right? But this is very invasive. This is electrocorticography, like they call it, embedding electrodes in the brain. They've been doing that for a long time, but the idea is that
Trying to do it.
yeah, it introduced not with as good a technology as what we have today, but the idea is that you have this. We'll call it minimally invasive, but I'm not so sure I can say that 100%. But it's a lot better than we did 20 years ago. The idea though is that now you have this connection, and it's not as subject to the noise and interference, though, right? This is where you get into some problems. When you get into semi-invasive and non-invasive, the semi-invasive, usually you connect directly, you connect over the brain, but not into the brain, right? And so there's very, very little risk of damaging the brain internally, right? Or, inducing inflammation, which is and less chance, of course, of any kind of we'll call it infection, right? But the intent here is that with semi-invasive, you can still manage to interface very closely with the brain. There's a one called the stentrode. It's a stent, and they put it just above the motor cortex, and this is kind of like a smart stent with all these electrodes in it. And then they use that because it's embedded within the brain, to measure ECG, CG, and that kind of operations, like electrostatic operations as well. Whereas there's other ones also that technically you can, through an interface that you remove part of the skull, and that you build this interface that applies over the brain, but it heals up fast and it doesn't go into the brain. It's a little. Well, it's not a subject to interference, and it's a lot more accurate, right? So semi-invasive is still an operation. The big money is going into, of course, non-invasive, the wearables, right? And that's where you get into, you don't have to worry about surgical risk, right? You can easily implement it. And then when you do, you do wear it or apply it, the intent is that it gets better over time. And that's because the interface itself is also utilizing AI to introduce improvements.
Yeah,
right?
like I said earlier, it's learning, right? And there's some breakthroughs in that area, right? Very, very recently, right? Mark Zuckerberg from Meta, or Facebook, as some people know him, they released at their conference a video of these new glasses, these Orion glasses, right, which are sort of augmented reality and so on. And part of that setup was actually a wristband that picks up on signals. So I guess, from that perspective, like I mentioned earlier when talking about Neuralink, right, the instinct is to send a signal from your brain to your hand. Well, if you're not somebody who's disabled, you're doing that when you're moving a mouse or using a keyboard. And the idea is that this wristband can pick up on those signals and then use those signals to move things around on a screen, or in this case within like augmented reality, which is really super interesting. I mean, to begin with, the fact that they've reached a point where this technology is actually working, and to what extent I'm not sure, because it's just in this very demo stage, but certainly over time it's going to get better and better and better. So it feels like we'll reach a point where things will be very non-invasive, and maybe the invasive methods are probably maybe more accurate right now, and maybe that's the reason why they've gone in that direction. But it seems like we're finding other ways in terms of wearables to pick up on signals, and for that matter, for a regular person using a computer, a lot of people deal with carpal tunnel syndrome or other things. And maybe that can eliminate that, right? So maybe you don't have to go as far as to get something implanted in your brain, but maybe we'll reach that new evolution of the interface between humans and technology, where we can control them more with our mind or with, more subtle movements and that type of thing. I think it's a really interesting area that we're heading into.
Yeah, and that's where there's a lot of interest, of course, because nobody wants to get an operation, right? But putting on a device on your head or wrapping something around your wrist, well, that's okay. We can do that, right? That's nothing to be afraid of. But think about the underlying technologies here, right? There's something called FNIRS. There's the standard EEG, right? Electroencephalography. There's magnetic, what they call them, MEG, but it's magnetic encephalography. And there's transcranial magnetic stimulation. And there's functional magnetic resonance, all tied, electromagnetism, right? Those are like all these technologies are all being utilized in some form already, and they're being investigated for further capabilities outside and more. We'll call it devices that are friendly and they don't have a lot of weight to them. They're lower cost. They have a large degree of accuracy. There's that's the main investment there is trying to get to the better device, right? Once you have the raw device, right, and it's able to process the information and obtain the information, then it's a matter of building the the AI type of bridging software to make sense of it, right? So, case in point, you look at that your EEG in your brain. It's a very complicated set of brain waves and patterns and peaks and valleys. And you think, okay, well, what's really going on there? And there's many different things that go on there, depending on what you're saying, what you're doing, and understanding all those patterns is the trick, right? Whether you're thinking about a color or sensation or a temperature or whatever, you can actually reflect on that. You can observe through your memory a specific sensation, and it will fire up those particular neurons in that brain of yours, and basically kind of simulate the actual, if it was actually happening. So this is very useful when it comes to trying to tie into those particular areas and communicate. So there's something called the hidden Markov models, and they use to discern brainwave signals and break down the patterns and understand. Basically what you're trying to do, of course, is evolve your understanding of how the brain manages complicated actions like movement, even calculations, perform mental calculations when you're in your speech and your basically any form of vision, right? The idea here is ultimately once you understand that, then you can model that from within your AI, and then you can figure out how to manipulate that so you can make a full duplex messaging protocol. So you go back and forth, right? So the mind can also be a receiver.
Yeah,
So,
it's a two-way street type thing. Yeah, in terms of the site, I noticed that in the news that Elon Musk's Neuralink got approval for this device called Blind Sight, which is going to help give blind people back their sight to some extent. I think initially it may just be more rudimentary, graphics and things to help them navigate, right? Something that pixel based maybe, but over time they may combine with other technologies. They may be able to sort of bring that back, which is interesting. The big challenge that back to that podcast I listened to was that, what they did with Neuralink with this initial subject was they implanted it in the brain to look at the center of the brain or the section of the brain that controls movement and so on, which is actually very much on the surface of the brain. So when basically they can just remove part of the skull and it's kind of right there. But when you get into sight and those types of things, now you're actually going deeper into the brain, and the more invasive you get, right, the deeper you're implanting things into the brain, the more risk there is, right? And the more potential for, rejection or other complications or even death, right? So that, obviously I haven't read enough on this particular blind site yet, but perhaps they've figured out something where they can go in so far and still pick up on those waves. But this is where we get back to non-invasive. It's probably the area that we're going to see grow even more. They'll probably take what they learned from these types of trials and apply it to non-invasive. But eventually, like any technology, it's going to get better in that respect. And I think anything that can help people who are blind or quadriplegic or whatever it is, get back those abilities and gain back some quality of life and most importantly, independence is massive, right? And there's a monetary reason behind it, obviously, with any technology company. But I think that the end result is certainly fantastic for humanity, right?
Yeah, I remember reading on I'm not sure maybe it was Ripley's, I don't know. But there's a specific individual, he had a spinal fluid issue. Basically, it built up pressure in his within his brain, and it pushed his brain through the outermost part of the skull, right? All the brain cells. So the mass of his brain was this very small, dense area on the very outside of the skull, and somehow he was a normal, functioning human being for the most part. Right? Mm. It was incredible, and it just denotes how through our neuroplasticity, how we can continue to function, and the amazing biology that we have today. So if you think about it, like you go back to this situation where you can't get at certain parts of your brain, right? But we internally can refocus and reprogram our own capabilities, right? So even with the fact that we won't be able to get at certain parts of the brain, we could also reprogram ourselves to focus in.
Yeah, for sure. It's interesting you said that, right? Because you can, if you look at people, I've heard oftentimes that when someone loses one sense, that other senses get enhanced, right? Yeah. So people that lose their sight sort of end up with this elevated sense of hearing, sort of like the Daredevil from the comic books, right? That he lost his sight and he could use hearing to the point where he could engage in hand-to-hand combat and other things with people. Obviously, that's in a more like science fiction realm, but it was playing off of the idea, right, that people that lose their sight oftentimes develop sort of super hearing of sorts, right? And I think that, and maybe things, the challenge right now is probably that we have to be more invasive to get closer to picking up those signals from the brain. But things like quantum computing and AI, the power of that to maybe take those low-level signals and interpret them and, produce better results is probably where it's headed, right? So it's probably a little bit more on the software and the computing side than it is on the hardware side, where this might certainly advance in coming years.
I wrote a story. One of my first novels was Bell Coast Dance. It was about a man, and basically kind of went a surgery with a brain interface, right? So essentially, he was tied into his ship, right, with all of its sensing capabilities and controls, and the super intelligence that also managed and ran the ship as well. So he had a neural interface with that. So if you can imagine having another body, right? Not a body like yours, but a body that is mechanical in nature, right? And you have all those sensors and all that information feeding back into you as well, for feedback. And let's take that. I know this is science fiction, but let's take it back to essentially being able to control your car, right? Or such, right? Mentally, or let's say you're a pilot, right? And instead of flying by stick, you're flying by mind. There's so much application here where we're going to become augmentations and connections to the bigger, mechanical /
It'll be
electromechanical
like Charles Xavier
intelligence.
from X-Men, right?
Yeah,
Controlling things with his telepathic powers type thing.
right. Well, I mean, that's the other side of the great mysteries of the beyond, about what we're capable of in our extra senses. But regardless of that, I mean, I'm just talking about what we know today and what we can do today, right? And
Mm-hmm.
there's a huge amount of capability here, and where it could, go. You talk about watch Dune. The navigator has been modified by the spice and blah blah blah, right? The idea is that there's a marriage, right? A marriage of the technologies and the body and the mind, right? And it becomes something else, right? The human pilots of tomorrow may be more integrated into their ships, starships, right? And they are part of the starship. Um, I know that sounds crazy, but the idea is that that's where it's capable of getting to, right? And with the technologies of today, as we're breaking ground, we're going to learn how to do this and do it safely, right?
Oh,
Um,
absolutely. I mean,
yeah,
it's not even that crazy, right? Because there's so many things that we think are crazy, or we thought were crazy years ago, and now everything's coming to fruition, right?
yeah,
We've got, even interestingly enough, we talked about this not too long when we did our wrap up on season one, where I said things we had talked about have come to fruition, and one of the things we talked about, in the second episode was sort of that real time translation piece, right? For example, not related to what we're talking about today, but in terms of possibilities of technology and where things can head. I mean, even when we talked about it then, there wasn't much going on with it. And yet, that's another thing that came out of this meta presentation, is that they've developed real time translation with these glasses, these Ray-Ban glasses they put out, to where he had a real time conversation with someone who was Italian, I believe, on stage, and they were talking back and forth in their native languages, and it was all getting translated in real time. Which we were talking about then, though that'd be a great advancement of technology, and yet months later we're seeing it start to emerge, and it
yeah.
seems like every day you turn on the news, there's some new technology emerging, and somebody figuring out something new and inventive. I even saw the other day of someone they called a real life Iron Man, and he's created an Iron Man suit that responds to his body, and is powered by some sort of hydrogen generator in the chest. I mean, he's basically built like the Iron Man suit, essentially. And when he flexes his arm muscle, this mechanical arm flexes with him, for example, right? So if you think about a regular person being able to wear an exosuit, exoskeleton, I guess, and that was always one of the things of science fiction, and now people are figuring out how to build it, right? So I guess for sort of science fiction geeks like us, it's pretty cool to see all these things that once existed in movies kind of come to life, before our very eyes.
Yeah, yeah. And the other thing too is that this technology has its roots in health, right, in healthcare,
Mm-hmm.
and restoring function, right, to the body. So we talk about BCI. What's the justification for performing, intrusive operations? Of course, it's about, if you have severe need and it justifies, right? So you're missing your legs, and you need to have that the capability to walk. The technology, you can bridge around the damaged area in your brain, right,
Mm-hmm.
or in your spine, or wherever it is. You can bridge around that, and you can control your arms and legs again, right? That's in there. It's an incredible thing we're talking about here, right? To be able to bridge the damaged areas, right? And you have to, it's a message the messaging you have to translate both ways. But the idea is that now we have technology kind of interfacing in between to make that happen and enabling that. So, spinal cord injuries, stroke victims, even degenerative diseases like ALS, traumatic brain injuries. Um, People often go through some form of trauma and damage, and they aren't able to talk, right? Or they are not able, they lose their hearing, or like you said, they're losing your sight. Restoring these senses, right? And this ability to move has incredible value. So this is
It's
great.
quality of life, right? It all comes
Yeah.
back to quality of life. There's so many people that suffer from these things. That was even part of the discussion around this Neuralink and this, huge podcast that I think it took me a week or two to listen to. I actually highly recommend it, that Lex Friedman had with the Neuralink team, right? He talked to the hardware maker, the surgeon, the software maker, and ultimately the guy that was involved. But part of the discussion was around, like you talked about, was like sort of fixing brains, right? So we've spent a lot of today talking about, those interfaces, to sort of allow them, to be able to control things and that type of thing. But they talked about, maybe a patient with Alzheimer's or something that's damaged in their brain, like you said, being able to fix that. Now they won't be able to bring back memories, but certainly they could fix what's wrong there, right? And that's certainly an interesting area whereby somebody can get back that quality of life. Again, maybe not bring back the memories, but maybe they can start making new ones that they can remember. And I think that's huge as well, right? So it's so multifaceted, the different sort of technologies and the way they can improve quality of life when it comes to the human brain. Really, the brain controls everything, right? And so when we really tap into that, there's a lot of different areas in which we can improve, life and that type of thing.
For sure. I mean, we think about, mental health, depression, anxiety, anger, fear, enhanced sensations like that, physiological induced states that nobody seems to be able to manage beyond that and improve. The answer isn't about meditation, or it's a physiological problem. It's a brain chemical issue. It's a metabolic issue. So what can you do about that? And that's, these types of interfaces can help, right? They can help in monitoring emotions and measuring, your state of relaxation and stress, and they can help, enhance biofeedbacks, uh, feed sensors to drive corrective measures, and through that, uh, you know, basically put your brain in, or force your brain into different states, right? And another key one is about inducing sleep, right? Improving the quality of sleep. People with chronic insomnia, there's a lot of them in this world. There's a lot of people out there that have sleep problems this day and age. This is huge, right? Being able to, utilize devices to help you sleep, right? And whereas that device is doing some fairly complicated things. Also, from a point of view of, this is where it gets really interesting. Not only can you help people, let's help improve people. Let's augment people. And this is where we get into that next stage, right? Developing the superhuman, right?
And back to the $1 billion man.
Yeah. So, I mean, the idea is, sure, you can do that. For instance, let's look at the mental side of things. You can, suppress fear. You want to create a super soldier, right? You can suppress fear and raise the ideas of confidence and things like that. Now, are there longer term dangers to this type of manipulation? I would say, yeah, the jury's still out. What is the longer term, right? We don't know. We're just beginning down this road, right? And there's, I mean, the souls that step up and volunteer for a lot of these operations, and procedures, when they know, 5 years down the road, they'll be a lot less intrusive and all, probably much more easier to adapt to. I mean, they're brave. Yeah, I got to give it to them, right?
Yeah, for
My
sure.
hat's off, right? To be able to say, okay, I will do it, right? I'll be the guinea pig, and I'll be the patient that is willing to try the initial, device interface and work through all of its bugs and problems.
Yeah, it's kind
And
of risk versus reward, right?
yeah,
And in fact, if you don't want to sit through the entire 8 hour podcast, just fast forward to the end and listen to this interview, with this sort of pioneer, right? This gentleman that got the implant, and I thought the most striking part of that, in terms of his motivations, actually, was gaining independence, right? So being a quadriplegic, he relies on everybody for everything, even as simple as turning on a computer. He had some interfaces, right, where he could sort of access and things, but he always relied on somebody else, right? And in this case, with the Neuralink, he can do everything himself. He can turn on the computer, he can interact with it, he can do all these things, and the big motivator was independence, right? And that's really where this is what happens a lot of times with people. And I've had my own experiences, around that, not myself, but with other people that end up in this state where it's really tough to lose your independence. You sort of lose your dignity. You rely on other people. And oftentimes that's sort of the common thread or theme that cuts through people who end up in these situations, or people who are older and things, is that they lose their independence, and in turn, sometimes their dignity, right? And getting that back was enough for him to say, yeah, let's do it. So I thought that was an interesting thing, and certainly made a lot of sense to me, right? And thankfully it worked. Thankfully he's off to the races, and he's using these devices, and who knows where it'll head for him. But like you said, hats off to him for taking that leap. Even though a lot of people would want it, how many people would want to get that holes drilled in their skull and the wires inserted? I mean, it was pioneering, right? In the sense that they had never done it before, and they didn't really know what was going to happen. And thankfully, it had a favorable outcome. And my understanding is just getting better for him. And in fact, it's more and more successful every day. But the system learns him, and he learns how to use the system. It's really quite remarkable.
yeah, it's hard for us to put ourselves into the position of somebody else who has these, types of situations and disabilities, and it's not an easy life, right? This basically goes back to live your life with gratitude, right? Now the other side of this too is, let's go back to the augmentation side.
Mm-hmm.
One of the key things that I even talked about in my book was the ability to learn, right? So you don't have to learn at the snail's pace that you normally learn at. You're able to digest and learn very quickly. I mean, they had the similar situation in Star Trek. I can't remember the episode. Anyway, the doctor had to. They stole Spock's brain, and they put it in a basically it was a computer running the whole colony, and of course they had to operate and put it back, and Bones had to be put on this headset, and it kind of downloaded all this knowledge,
Mm-hmm.
right, of him being able to perform this, very complicated task of basically putting a brain back into a head, which we can't do today. But okay, and anyway, so that that was way back then, right? Even in the Matrix, they talk about oh, you don't know kung fu, now you do, right?
That's right. That's funny, actually, because I was thinking the exact same thing just then
Yeah.
when you were talking. I was going to bring up the thing from the Matrix where he learns kung fu instantly,
Yeah,
right?
yeah.
And then we see that with the current AI and large language models, and how much they can learn, how fast they can learn it, right? And we're not haven't even reached super intelligence yet. So
Yeah.
if we can have that direct interaction or direct input into our brains, I mean, who knows where that can lead, right? And again, we're talking science fiction, but I
Are
tell
we?
you, everything
Yeah.
that was in science fiction 10 years ago, not everything, but a lot of what we saw 10 years ago seems to be coming true today. So it's maybe not that far-fetched, right?
Yeah. And let's say you have you have an Olympic athlete who's able to perform some amazing things physically, right? And they're able to download, and you're able to upload, and you can, even though you're physically, you may not have the capabilities of of performing at the same state, you now have the mental capability that you've learned, right?
Mm-hmm.
This is a whole new area, right? Of not only understanding how we're able to learn things and where we're storing things and how we're able to convey that information, but it's a whole thing about being able to accelerate ourselves. It's augmenting ourselves and becoming superhuman.
Oh, there you go. I mean,
Yeah.
think about it. Let's take this to an even greater realm of science fiction. So there's a television show that me and my wife have been watching for a couple of seasons now. We'll see if it continues. Called Upload. I believe it's on
Oh yeah.
Amazon Prime,
Yeah.
where they basically figure out how to upload people's brains into this virtual world where they can sort of live forever, type thing. Which is basically the idea, I guess, is that can you take someone's brain and then replicate that in a virtual form to where you sort of live on forever, and then would it actually be you living on forever if they can completely replicate your brain, right? Because we're in these these fleshy pods here that aren't going to last forever. So might we see that at some point, even in our lifetime? I mean, who knows? But then we might end up like the vampire that lives for 600 years and just is tired of living at that point, right? There was maybe that was an interview with the vampire where he didn't want to. There was some way for him not to become a vampire anymore, and he chose that route, and someone just couldn't understand it. You get to live forever, you get to see everything, and he kind of said, "Well, I'm kind of tired. I've seen enough. It's been 600 years. Like I'm done. I'm ready to move on," type thing, right? So, back to that. Even if we can do it, should we do it? And then you end up with situations where maybe you have a loved one that can continue on in virtual form, so you can continue to interact with them and have conversations with them and that type of thing. But is it really them? I think in an earlier episode I mentioned the show Orphan Black Echoes, which was a continuation of the original Orphan Black, which was all centered around human cloning. One of the best science fiction shows of all time, in my opinion. But in this one, the scientist had brought back her wife that had passed away, and the question was, well, is it really still her? Right? They used the DNA and everything to bring it back, but is it really still her? And I guess that sort of comes back to some of our conversations in the to imitate us to create episode where we talked about what it means to be human, and that we have a soul and we have a heart, right? So even if you could replicate a brain, is that really the entire person per se, right? Or is it a replica of sorts? So anyway, I know we're getting way into science fiction here, but when we start to get into interpreting brains and that type of thing, could we reach a point where we could actually like replicate a brain? That's sort of the stuff of science fiction, but we'll see. All right.
Yeah. I think the idea is, we're utilizing our own ability to observe and learn from ourselves and trying to apply that out to the outside to build, our own type of machines and with the expectation that, they're going to work as well. Right. I've yet to see that happen, but regardless of that, it's a good goal to aspire to. If we think about it from a point of view of addressing, the critical functions of disease and injury and disability, and helping, our fellow man, I think this type of technology is absolutely the way to go. There's, and there's a lot of convergence. We talk about, in the series about convergence of materials and manufacturing and new designs, and you see that all with all the new prosthetics that are coming out. Incredible, right?
Mm-hmm.
And you also see it, the idea of how do you build a better, robot, right? How do you make better limbs? And all that technology now is going into prosthetics as well. So, this, as we're learning and we're adopting and we're being able to figure this stuff out and share it, that's where it gets interesting, right? Is how much do you share and how much is copyrighted, right? Because if you're copyrighted forever, then you're not sharing, right?
Mm-hmm.
So this is where I'm open technology and open learning. This is really going to, think about what NASA's done, for instance. A lot of that was open technology in a lot of ways, right? They were the kind of the first, uh, you know, uh, international company that shared a lot of what they learned, right? And it wasn't closed off. And this is the type of, capability that we need to continue to do. And we see that in the software world, but no, that's just seeing it outside in the outskirts of, the mechanical and the device and all that kind of thing. So we got to continue to push for that, all right, where everything is not closed and for the profit, you cannot access because of, right,
There's
you don't
open
own it.
source and that type of thing.
Yeah, yeah. If you're, as another producer, you're able to utilize those technologies and build something else, right? Greater. I mean, that's really what it's all about, right? So that's another spin on the economy and how we have things configured today and licensing and copyright and all that fun stuff. But I do think we need to improve on that as well in order to truly expand and build a world of the future that supports us, right, as a humankind, right, in a better way, right.
Yeah, absolutely.
Yeah, and that being said, there is just to talk about government right now. The governments are really starting to look ahead on utilization of this technology. Um, the U.S. is far ahead of the other countries out there right now, probably because of Elon,
Yeah.
he's pretty active integration points on lobbyists in the government. But so the FDA is fairly advanced in this whole idea of, building, Neuralinks and, BCI technology. But the UK and Europe, they're all starting to move on this as well. And with that, of course, is the idea of value, risk, human trial, the scope of trials, the what's the evaluation criteria from a point of view of being able to say, this technology can be released and used en masse. There's a lot of questions out there and a lot of challenges around building up, the governance around that. But I think we need to be just as aggressive on that.
Yeah, it's like anything else, right?
Yeah,
We're introducing a new technology. In this case, we're interfacing with, human biology, and there might be a lot of people that want to take that route that have disabilities and other impairments, but if it's done without sort of regulation and oversight, what might happen there, right? Because there will be an emotional need to want to participate in these things. But if on the other side there's not some checks and balances and so on, there might be some challenges there, right? So that kind of leads into the idea around, ethical and privacy concerns and different things that we need to consider, right? Because we talked about all the amazing potential here, but like anything, as we talked about a lot of the AI in the first season and the need for oversight and balance and these things, I think the same types of things apply here, right? In that we want to make sure that we don't have some mad scientist that creates something that ends up being sort of mind control, right? Right now, obviously, you'd have to get surgery for something, but when we get into wearables and non-intrusive, now we're getting into a whole different realm of technology and interactions and things like that, right? And who knows, maybe even being able to read minds in the future. So it's
yeah.
it's a pretty wild area that again sounds like science fiction. Maybe in 3, 4, 5 years is not, right. So what do you think about some of the sort of challenges and concerns and that type of thing around this technology?
Well, there's a lot. Like you talked about a little bit about the ethical and privacy is. We may, just because we have a technology doesn't mean we want to utilize that. And there may be ethics from a point of view of, we implemented a technology, but we know it doesn't have a substantial lifetime to it, right? We don't understand the long-term effects to the patient, right? Could that do more harm, right?
Mm-hmm.
So there's definitely that. what about security? You know, a lot of these devices, if they're storing information, history, you know, they're picking up all the data from our surrounding area. Does that mean now that you've become, you know, a point of interest to, you know, download information from, to know everything about where you're going and what you've been doing? You know, let's say if you're working for the government and or, you know, kind of espionage thing or something like that, that you know, because of your, you know, your we'll call it your arm, let's say, has been replaced, right? Now you have all this technology that is, you know, storing, and sensors are tracking information, and it's also integrating all that information with, you know, your location transference, and it's communicating back and forth on the cloud. All of a sudden now you become a you know, an area of information that we could use, some, you know, a bad actor could use to you know, infiltrate, right? So there's that. There's you know, the idea of what are the ethics around the, you know, implementing proper regulation that doesn't harm learning and growth, but at the same time supports the patient, right? But we just talked about that a little bit. What is the, you know, what is the lifetime of this technology, and what can you do about it, right? Even with the Neuralinks, they talked about, you know, technology that has, when you put it in the skull, you have this battery that's in there, and can that be taken out, right? And can that piece be replaced, right? Without having to redo all the links, right? So, you know, there's a plate, and that everything goes to the plate, and the plate has all the connections into the brain. But, you know, you can remove this main battery component, please, and put a new one in with a very limited amount of effort, right? You have to really think about that, like what the long-term maintenance of a lot of these devices, right?
Yeah, like even the Neuralink does have it has to be recharged. It is communicating via Bluetooth. There's all these different considerations around it,
Yeah.
and like anything, it's new. And have we studied it enough, right?
Yeah.
And to our point in you know, earlier conversations around superintelligence, how fast are we moving in this direction, right?
Yeah.
And are we, you know, it all seems fantastic, but sometimes when you move too fast, you don't do enough testing. You don't understand the implications, and now next thing you know, you discover something that's, you know, potentially life-altering complication that now it's implanted in, you know, 8,000 people, for example, right?
Exactly. Yeah.
And
You could have some kind of prosthetic that is, you know, you have the interfacing technology, but that interfacing technology, you know, I don't know, you go down the subway and somebody's got the latest radio or some device for listening to music, and it makes your you know, prosthetic go crazy, right? And you go, well, what happened, right? That these you know, the idea of how you're affecting your environment, what kind of sensitivities does this technology have with the environment? You have to really think about all that, and you have to make sure that these devices ultimately are safe, right? They have a shutdown, you know, a safe shutdown capability. You talked about your drone, right? A little while ago, you know, piloting your drone, a bloody thing took off on you. Technically speaking, those things are supposed to, when they lose connection, they're supposed to go home. You know,
yeah.
ET go home, right? But it didn't quite do that, did it?
Yeah, well, like any technology, it has propensity sometimes to just kind of go sideways for no good reason, right? And it's yeah, I think there's certainly a lot of things in terms of, you know, ethical concerns, and as well as sort of the dangers around these devices, because at the end of the day, you're interfacing, you know, machine with man. It's not really natural, and some of that comes back to, you know, like even in, like I mentioned, Orphan Black earlier, you know, the idea of human cloning is unethical and still is considered, you know, largely unethical. But there hasn't been maybe as much conversation around ethics around this technology and what it really means. Like some people might think, oh, we're playing God, even if we're doing good, right? Even if we're helping people fix things that are wrong with their brain or giving people the ability to control things who are paraplegic and that type of thing, you're still in a sense playing God, right? And even if it's for the greater good, I think there's still a lot of things to think about there, right? But where do we think things are headed now? Like now in terms of the future of the technology, we talked a lot about it, but maybe in the more near future, like where do we see things headed?
Well, I think that we're going to see the technology continue to improve, right? Whether it be the tiny little pill that is internally as a robot, little nanobot, or finer elements, that are being electrodes that are being used for connecting to specific cells in your in your brain. But when we think about the technology itself, the idea too is that technology just doesn't encompass the mechanical. Technology also nowadays is we've got biotechnology as well, right? So the technology itself is a little more complicated. So we're going to see that, right? The marriage and learning of biotechnology in order to interface with us, right? And that biotechnology can be cloned or grown or whatever, but also be modified from a point of view of being that bridge in between, the hard mechanical or electronic technology and our systems, right? So I think we're going to see a lot of that. We're also going to continue to see the expansion of the bridging software systems, right? We'll call them, that's the AI side of things. And it's also quantum, computing and all that kind of thing. We're going to see systems that are better able to understand the patterns and the information that they're getting to further refine the specific direction and commands that you want to perform from the mind, right? Because there's a lot of noise, right? And you got to break through that noise. And what is it you want to do, right? I want to move my hand. I want to move my finger on a prosthetic limb, right? So that's what we have. Lots of improvement on that. Along with, I talked about the technology that we're utilizing for these limbs and any kind of prosthetics and any kind of augmentation. We're also going to see other types of interface technologies that are going to be coming out. The idea of functional MRI. Right now, that we have a very large piece of equipment, but that's been shrunk down now. The head outfits, and we'll get down to a headband, right?
We're seeing a lot of the technology move into for example, we're seeing it move into more of the mainstream. If you look at even not too long ago, a couple of weeks ago, Apple came out with a presentation and they're starting to integrate a lot of this AI into their devices. You can take a hearing test using Apple AirPods, and the Apple Watch now can read blood oxygen levels and other things, right? And they have to get FDA approval. These are turning into sort of wearable medical devices. And now I think what we're going to see is a certain aspect of non-intrusive wearable devices going more mainstream. And I think it's going to be interesting to see where that goes, because it's going to be, maybe not as impactful as these more invasive type things, but it's certainly going to open up a whole wide world of possibilities. We already see some indications of being able to exoskeletons and being able to wear something and lift really heavy things, right? And kind of turning us into superhumans, as it were, using devices to, even the AirPods now can isolate and take out sounds in the room so you can better hear somebody, right? We're getting into that sort of realm of, in a sense of having superpowers, and maybe we can, eventually we'll all be the $6 million man. There we go.
The guy in the tin can.
Yeah. We're aging ourselves, but that was the big show back in the day, the $6 million man, right? They remade him to be bigger, stronger, faster. So
yeah,
that's what I'm looking forward, Patrick, as we're into our 50s now. We can become the $6 million man, or again with the conversion rate to modern day economy, will be the $1 billion man.
Thank you for listening to the Probability Podcast. Please join us next time for more musings from the generator and the discriminator.